Very good morning to all of you. Myself, K. Srikanth, Associate Professor of ECS Department at GPRC Kurnool. And today's topic it is object-oriented principles. Let us start the session. So in the object-oriented principles, we like to understand what is an object, what an object consists of, what is a class, and what are the object-oriented concepts that are used to develop applications. As we all know that Java is a object-oriented programming language, and it covers the following important principles to develop an application. So first we focus on a keyword called object. Let us understand what object exactly it means. So, so generally an object, it consists of, so I just write here, say object, it is an instance of a class it is an instance of a class. So first we need to write a class where a class consists of methods and variables, instance variables. For a class we can create n number of objects, so we can create any number of objects for a defined class, and every object has the following things, that is object state. So the object state, it represents the values of the attributes or variables that are part of a class. Then an object consists of behavior, so which we represent with methods of the object. And an object consists an identity, so whenever we create an object, the JVM will assign a unique ID for every object, unique ID for every object. So this unique ID is enabled to interact with other objects. Then within a class we write methods. So we all know that method is a collection of statements to complete a given task. So we can perform a specific task using a method, and it can be called any number of times, so where we get a property called reusing the code. So by this we can save our time. So overall, so we come to know what is an object. So an object is an instance of a class. So an object have the following things. So one is the object state, which represents the attributes of a class, and it consists of a behavior, so which represents the methods of an object, and object identity, which is unique ID for every object that we created. And every class, it defines the methods. So to perform a specific task, by using these methods we can get a reusability feature, and we can save our time to execute the same code time and time. And here I write the two keywords what we try to understand. So one is a class. So a class, it is a combination of so a class, it consists of variables. So generally we call it as instance variables. and it consists of methods, and it also we can write constructors. So in the coming videos, we discuss in detail about this, what a instance variable is, how we need to define the method within a class, and how to write a constructor, and what is the use of constructor. So before creating an object, so we need to write a class which consists of instance variables, methods, and constructors. So for a class, so for a written class, we can create n number of objects, and we will discuss how to create objects and what an objects. So whenever we create an object, so it has variables, the class variables, the class methods, and the class constructors. That's why so that is what we discussed in the previous slides. So the variables values, we are calling it as state. The method definitions, we are calling it as behavior. And every object has unique ID, that is identity. Unique ID. So the class is it is a logical entity. So the class, we call it as logical entity, so for which no memory is allocated. So it is like a template to create objects. So but whereas object, it is a physical entity. So physical entity means it the compiler allocates memory, right? So so the object, every object has memory. So the memory for the class variables, the memory for methods, the memory for constructors. So this is a very basic concept of class and object. So first we need to write a class, because the Java is supporting object-oriented principles. So it is mandatory to know how to write a class and what a class consists of. The class consists of variables, methods, and constructors. So for a written class, we can create objects, and every object has state, behavior, and identity, that is unique ID, right? So let us discuss the 4 basic principles of object-oriented programming. So here it is listed. One is encapsulation, inheritance, polymorphism, and abstraction. So these 4 principles are very important and popular, so to write real-time applications. So let us discuss one by one. So what is an encapsulation first? So encapsulation so generally binding. So encapsulation in shortcut, so we can say the binding data is nothing but your variables so encapsulation, so in shortcut, so encapsulation, so we can say that binding of data, so data is nothing but your variables, and so behavior, so behavior is nothing but your methods in a block. So that is what we are calling it as a class, right? So if you write a class, it has variables and methods. So we need to put, so the binding is nothing but we need to put the variables and methods in at one particular place, right, to achieve a feature called encapsulation. right? So generally to make the data secure, right? So variables, generally the data it's stored in variables, right? So to make the variables secure, so generally we make the data as private. So the Java language, it has 4 access specifiers, right? Access specifiers. So one is private, the other one is public, protected, and no modifier, right? So so the private, when you make the variables as private, it can be accessed within the class, not outside the class, right? So when it comes to methods, you have to make the methods as public, so to access outside the class, right? So generally to provide security, we need to make the security of data, so the variables are declared as private, and to so to complete the behavior of the class, so we need to make the methods as public, so where the methods will work with the variables of the class. So here we can see that state are stored privately. So state is nothing but your variables. So we have to make the variables as private, so which cannot be accessed outside the class. So whereas we need to make the methods or functions of a class as public, so that we can interact with your data using methods outside the class, right? So it is like data hiding, security to your object state, right? And we can reduce the risk of errors and makes the program more understandable, right? So in overall so we need to, so encapsulation is nothing but combining your data and methods at one place, that is your class, right? So class, we need to write class with private variables and public methods, so to achieve encapsulation. So in overall, so we can define in this way, right? So to achieve the principal encapsulation, we need to write a class where the variables has to make private and the methods has to make public. So the private variables can be accessed within the class, so whereas methods are public, so it can be accessed outside the class to work with private variables within the class. So then comes the second principle, which is inheritance. So inheritance is a popular principle, so where we can achieve a reusability feature. So reusability feature so in using encapsulation, reusability feature, right? So here we achieve a relationship called parent-child relationship. Parent-child relationship. So first we need to write a class which is called as parent class, and we need to write one more class called child class, which use the parent class features, and the child class have its own features, right? So parent class is already available, which can be reused by creating one more class called child. So we need to go with a keyword called extends. We have a keyword called extends in Java language to use the parent class within the child class. So whenever you extend parent class to the child class, all the properties and behavior that are part of parent class all inherited into child class. and the child class have its own variables, methods, which is nothing but your we can say extensibility of the application, right? So we using inheritance, we can extend our application, right? So where lot of code that is already present in your parent class, now you want to create a child class which use the parent class features, and it can extend its own features, right? So using inheritance, we can prevent code duplication, so no need to write with the code which is already available with you, right? So we can create the parent class and we can use the logic of parent class in the child class. So right, so one more thing we need, one advantage with this inheritance is that, so we no need to create objects for all the classes that are there in your application. So if you go with inheritance, we can create object only for the child class, and using the child class object we can access the parent classes methods or variables very easily. So using inheritance, so it reduces the complexity of the code, and it eliminates the need to create a new object for each object used in the program, right? So that is what I said that so it is not necessary to create object for all the classes that are available in the application. It is it is okay if you create object for the subclass, so which inherits all the parent classes that are available in your application. So then we have one more principle called polymorphism, right? So in general, the polymorphism, we can define in this way. So the poly, it stands for many, whereas the morph, it stands for forms. So so we need to understand that. So so when you call a method, and the method is reacting in many forms, right? So we have different classes to perform actions with same name but using different code, right? So here a simple example is given to us, so where we have a method called show information. So it works with different objects, right? So let us suppose we have a car object, it has its own show information method, right? If you have an object called plane, it has its own show information method. If we have a object called ship, it has its own show information method, right? So the method, it is common for all the objects, but the the results, they are different for car, plane and ship. So generally the polymorphism, it is used to create more flexible and modular programs. So the main intention of polymorphism, it is again of two types, static polymorphism, or we can say compile time polymorphism. So compile time polymorphism, and we have dynamic or runtime polymorphism. So this static polymorphism we can achieve by using method overloading. So these topics we will discuss in detail in the coming videos with Java examples, right? So to achieve method overloading, dynamic polymorphism, so we need to have method overriding plus inheritance concept. So we need to combine both the concepts to achieve dynamic polymorphism or runtime polymorphism. So so the overall intention is that, so if there is a method that you have defined in lot of objects, right, and this method, it gives different outputs. So output 1, output 2, output 3 and output 4, right, based on the object it is acting on. So this method is available in more number of objects, right? So based on the object, we get different outputs. It is available in more number of objects, right? Then the last principle, that is abstraction, right? So generally abstraction, it is nothing but hiding the essential details, hiding the complexity. So whatever the complexity that is there in your the program, you need to hide it, and you need to provide basic interface to interact with your application, right? So abstraction is nothing but hiding the complexity and providing the basic interface to work with your application. So in Java, to achieve, so here in this slide an example called movie is taken, right? So where for a movie the most essential details are title, release year and genre, while hiding the least important details. So we need to hide the less important information like shorts or technical aspects, right? So whatever the important details that are required, we need to give it as an interface, and we need to hide the complexity. So that is the overall intention of the abstraction, right? And this abstraction can be achieved in Java by using two concepts. One is abstract class. So abstract class, using abstract class we can achieve from 1 to 100% abstraction, right? And we have interfaces, right? So interfaces, it gives 100% abstraction, pure 100% abstraction, right? And this about this abstract class and interfaces we will discuss in the coming videos, right? So at present, I like to introduce the basic introduction to the object-oriented principles. So later we discuss in detail one by one with Java examples, right? So then you come to understand what exactly these principles are and how we need to apply in the real-time applications. This is what today's content. So I just like to revise what we discussed today. So in the today's topic, so we like to come to know what is a class, right? So what a class consists of. A class consists of instance variables, methods and constructors, right? And what is an object? So object is an instance of a class. So for a available class we can create n number of objects, right? So for every object memory is allocated in the RAM. So for a class no memory allocation is done, so that's why it is called as physical entity. Class is a physical entity, sorry, class is a logical entity and the object is a physical entity. So because memory allocation is done for the objects. So then we come to know the object oriented principles. The first principle, it is encapsulation, right? So in encapsulation we need to put data and behavior at one place. So that is a class, so where we can put our instance variables and methods at one place, and making the variables private and making the methods public, we can achieve the property called encapsulation. So then we come to know what is inheritance. So an inheritance is nothing but reusing the features of parent class to the child class. And we have different types of inheritance: single level inheritance, multi-level, hierarchical, multiple and hybrid inheritance. In about this type of inheritance we will discuss in the coming videos. So overall the inheritance advantage is to reuse the code that is already available in the parent classes, that to be brought into the child class, and the child class, it can define its own variables, methods to extend the functionality of the existing class. So then we have polymorphism. So polymorphism is nothing but making a method to react in different formats based on the object's reaction, right? So achieving many forms. So poly means many and morph means forms, right? So a single method is reacting in different ways based on the object input. And the last one, it is abstraction. The abstraction is nothing but hiding the complexity and giving the most essential features to the customer or the user, right? So that he can use the application in a user friendly format, right? So it is not necessary to give all the details to the user, so which makes the application complex, right? uh, that's what today's video. Thank you for listening to my video. So I will come with one more video with a new topic. Thank you.